Drugs in water is a growing concern. As humanity grows, so does the intake of drugs. There are various sources ranging from landfill leachate to simply being flushed down the toilet. One drug of concern is codeine. While it may not have severe side effects compared to other drugs, it is an opiate. In being so, constant consumption can lead to addiction, followed by overdosing and even death. We sought to determine a method in which to convert codeine into a form where it would no longer be of concern. After researching, it was determined that this could be achieved through ozonation. When codeine is in contact with ozone and water, it will react and change the color of the water. To prove the effectiveness of said approach, we created multiple trials with potassium iodide as a substitute for codeine, as it also produces a change in color when in contact with ozone.
Potassium iodide in the large bucket filled with water to a height of about 6 inches. Then we placed the diffuser stone about 4 inches deep from the surface of the water. We set the ozone generator to its 5th setting, which was about 20 minutes. We let the system run and took pictures from 0 minutes to 20 minutes. For the second trial, we also used the same concentration of potassium iodide in water, but instead of 20 minutes, we ran it for 10 minutes. Then for trial 3 and 4, we used the same exact amount of potassium iodide, but we filled the bucket to about 3 inches, ran the system for 10 minutes the first time, emptied it, set it up again, ran it for 20 minutes. We were taking pictures every 5 minutes for the 10-minute trial and every 10 minutes for the 20-minute trials.
Here's our original model, and next we will show footage from the experiment.
Right now we are putting 15.6 grams of potassium iodide into a bucket of water with a height of 7.62 centimeters. Now we're mixing it in order to get the potassium iodide equally distributed throughout the water. Now we're going to place the dispersion stone into the water, turn on the ozone generator, and have it run for 10 minutes.
Our results show that initial concentration of potassium iodide affects the rate at which the reaction occurs. We found that the greater the initial concentration, the faster the rate of reaction. The potassium iodide and ozone have reacted to produce potassium hydroxide, oxygen, and iodine. We can tell that the potassium iodide has undergone a reaction because a change in color of the solution indicates that the reaction has occurred. For our trials with only 3 inches of water, there was a greater initial concentration, and the rate of the reaction was faster than the trials with 6 inches of water. The top row in this picture shows the progression of the reaction with 6 inches of water, whereas the second row is with 3 inches of water. As we can see, since the height of the water and initial concentration are indirectly related, the rate of the reaction for 3 inches of water is greater than the reaction with 6 inches of water. If the rate of the reaction is fast, then the concentration of potassium iodide, or codeine, decreases more quickly. Since we could not quantitatively measure the concentration of potassium iodide in the water, we created a model that represents this rate of reaction. Although the actual rate of reaction is not linear, but rather follows exponential decay, this model utilizes the main variables associated with this experiment: initial concentration and time. As we can see, the slope of the trial with 3 inches of water is greater than the trial with 6 inches of water, indicating a faster rate.
In conclusion, this experiment was conducted to simulate the intrusion of codeine into a waterway and use potassium iodide as a pollutant and ozone as an indicator to break down the potassium iodide into iodine. This was evident by the yellow coloring of the solution. The purpose was to indicate the presence of a toxic chemical in the body of water and remove it after using ozone as a catalyst to break down the chemical. We determined that the concentration will break down quicker in a smaller body of water because there is less liquid for the solvent particles to move around in. The breakdown of the potassium iodide is meant to show the breaking down of our hypothetical codeine into a less toxic pollutant in our body of water.